Imagine a cat, sealed inside a box, its fate tied to the whims of a single radioactive atom. If the atom decays, an event governed entirely by the probabilistic laws of quantum mechanics, a vial of poison is shattered, and the cat dies. If the atom does not decay, the cat lives. According to our classical everyday intuition, the cat inside the box is definitively either one or the other. We simply do not know which until we open the box and look. But this is not what quantum mechanics tells us. It tells us something far stranger, something that strikes at the very heart of our understanding of reality. It tells us that until the moment of observation, the atom exists in a superposition of states. It is both decayed and not decayed simultaneously. And because the cat's fate is inextricably linked to the atoms, the cat, too, must exist in a superposition. It is, in the bizarre language of quantum physics, both alive and dead at the same time, a ghostly blend of two mutually exclusive realities coexisting in a single, unobserved space. This is Erwin Schrödinger's famous thought experiment, and it was not designed to be a literal description of feline biology, but rather a dramatic, macroscopic metaphor to expose the profound absurdity and the deep philosophical paradox that arises when the strange rules of the quantum world are scaled up to the world of our everyday experience. We never see a cat that is both alive and dead. The moment we open the box, the moment we make a measurement, this cloud of possibilities, this wave function, collapses into a single, definite reality. The cat is either alive or it is dead. The act of observation seems to be the trigger that forces the universe to make a choice. But how? And why? This is the quantum measurement problem, one of the deepest and most unresolved mysteries in all of science. It forces us to ask a question that feels more philosophical than physical. Does reality exist independently of our observation of it? Or is the universe a participatory one, a reality that only solidifies, only becomes real when a conscious observer, or at least a measuring device, interacts with it? This idea is not just a scientific curiosity. It is a profound challenge to our sense of an objective, external world. It suggests that the boundary between the observer and the observed is not as clear as we once thought, that we are not passive spectators watching a pre-existing cosmic drama, but active participants co-creating the script as we go along. Schrödinger's cat, in its sealed box, becomes a symbol for every unobserved potential, every undecided future, every unexamined corner of our own consciousness. It is a metaphor for the state of our own minds as we drift into sleep, a state where the rigid certainties of the waking world dissolve, where logic and contradiction can coexist, where we are both here and not here, both ourselves and someone else entirely. In the comforting darkness of this quantum uncertainty, we surrender the act of measurement and allow ourselves to float in the pure, uncollapsed sea of possibility, a sea from which all realities, both in the cosmos and in our own minds, are born. The strange state of Schrödinger's cat is built upon the foundational principle of quantum superposition, a concept that is as fundamental to the quantum world as gravity is to the classical one. Superposition dictates that a quantum system, like an electron or a photon, can exist in a combination of multiple, seemingly contradictory states at the same time. As long as it is not being measured, an electron does not have a single, definite position. It exists as a probability wave, a cloud of potential locations spread out over a region of space. It is not here or there. It is, in a sense, both here and there. A photon can be polarized both vertically and horizontally simultaneously. An atom can be in both a high energy and a low energy state at once. This is not a matter of our ignorance. It is not that we simply do not know the particle's true state. The particle's true state is this combination of all possible states. The most famous and elegant demonstration of this is the double-slit experiment. If you fire a single electron at a barrier with two slits in it, and you do not watch to see which slit it goes through, the electron behaves not like a particle, but like a wave. It seems to pass through both slits at the same time, creating an interference pattern on the detector screen behind the barrier, a series of bright and dark bands that is the classic signature of two waves interfering with each other. It is as if the electron's own probability wave splits, passes through both slits, and then interferes with itself, This happens even if you fire only one electron at a time. The single electron, somehow, knows about the existence of both paths and behaves accordingly. However, the moment you place a detector at one of the slits to see which path the electron takes, the magic disappears. The interference pattern vanishes. The electron behaves like a well-behaved particle, passing through one slit or the other, but not both. The very act of measurement, of gaining information about the electron's path, forces it to abandon its wave-like superpositional nature and choose a single, definite reality. This is not just an abstract concept, it is the engine behind the next technological revolution. The power of quantum computers lies in their ability to harness superposition. A classical computer bit can be either a 0 or a 1, but a quantum bit, or qubit, can be a 0, a 1, or a superposition of both at the same time. This allows a quantum computer to perform a vast number of calculations simultaneously, giving it the potential to solve problems that are intractable for even the most powerful classical supercomputers. But perhaps the most fascinating aspect of superposition is its echo in our own subjective experience. As we lie on the edge of sleep, in the hypnagogic state, our minds enter a similar realm of fluid possibility. The rigid categories of waking thought dissolve. We are not fully awake, nor fully asleep. Memories, thoughts, and images from different times and places can coexist and merge in strange and beautiful ways. We can feel both the comfort of our bed and the sensation of floating in a distant, imagined landscape. This is a mental superposition, a state where the mind is no longer collapsed into a single, definite stream of consciousness, but exists as a shimmering cloud of potential experiences. It is in this state that the seeds of our dreams are sown, a state where the strict logic of the classical world gives way to the poetic, associative logic of the quantum realm. Superposition is not just a mathematical tool for physicists, it is an invitation to see the world, and ourselves, not as a collection of fixed, solid objects, but as a dynamic, vibrant, and endlessly creative sea of possibilities. The transition from the probabilistic, superpositional world of quantum mechanics to the definite, classical world of our everyday experience is known as the collapse of the wave function, and it lies at the heart of the quantum measurement problem. The wave function is the mathematical object that describes the probability cloud of a quantum system. It contains all the information about all the possible states the system can be in. As long as the system is isolated, the wave function evolves smoothly and predictably according to the Schrödinger equation, a continuous, wave-like evolution. But the moment a measurement is made, something dramatic and discontinuous happens. The wave function instantaneously collapses, and only one of the many possibilities becomes the single, actual reality. This collapse is not described by the Schrödinger equation, it is a separate, ad hoc rule that we have to add to the theory to make it match our observations. But what constitutes a measurement? What is the magical ingredient that causes this collapse? This is the question that has divided physicists for a century. The Copenhagen interpretation, the historical orthodoxy developed by Niels Bohr and Werner Heisenberg, takes a pragmatic and somewhat mysterious view. It posits a fundamental split between the quantum world and the classical world of our measuring devices. When a quantum system interacts with a classical measuring device, the collapse just happens. The interpretation does not explain how or why it happens, it simply states that it does, and that our job as physicists is to calculate the probabilities of the different outcomes. This is a deeply unsatisfying answer for many, as it leaves the boundary between quantum and classical ill-defined and elevates measurement to a special, almost mystical, status. In response to this dissatisfaction, other interpretations have been proposed. The many worlds interpretation, first proposed by Hugh Everett III, offers a radical and elegant solution. There is no collapse. The wave function never collapses. When a measurement is made, all possible outcomes actually happen. The universe itself splits or branches into multiple parallel universes, one for each possible outcome. In one universe, the atom in Schrödinger's box decays and the cat is dead. In another, it does not, and the cat is alive. The observer also splits, with one version of you seeing the dead cat and another version seeing the living one. In this view, measurement is not an act that collapses reality, it is an act that entangles the observer with the system. splitting the world into different non-communicating branches. There is no special measurement process. There is only the smooth, continuous evolution of the universal wave function. Another class of theories, known as objective collapse or spontaneous collapse models, proposes that the collapse is a real physical process. It is not caused by an observer, but happens spontaneously and randomly. For a single particle, this spontaneous collapse is incredibly rare, but for a macroscopic object, which consists of a vast number of particles, the probability of one of them collapsing becomes incredibly high, leading to an almost instantaneous collapse of the entire object's wave function. This is why we never see macroscopic objects like cats in a superposition. They are simply too large and complex to maintain their quantum coherence for any significant amount of time. The measurement problem remains one of the most profound and open questions in all of science. It is a question that probes the very nature of reality, the role of the observer, and the boundary between the potential and the actual. And it is a question that resonates with the experience of falling asleep. As we close our eyes and turn our attention inward, the constant stream of measurements from the external world ceases. The neural windows of perception close, and our consciousness is no longer being constantly collapsed by the influx of sensory data. It is in this state of sensory deprivation that the mind is free to explore its own internal quantum universe, a universe of uncollapsed possibilities, of fluid associations, of dream-like superposition. The act of sleeping is, in a sense, a voluntary suspension of the measurement process, an act of surrendering to the pure, uncollapsed potential of our own consciousness. The inherent fuzziness of the quantum world, the fact that a particle can be in many places at once, is inextricably linked to another fundamental principle, Heisenberg's uncertainty principle. This principle is not a statement about the limitations of our measuring devices. It is a fundamental, built-in property of the universe itself. It states that there are certain pairs of physical properties, known as conjugate variables, that cannot both be known with perfect precision at the same time. The most famous of these pairs is position and momentum. The more precisely you measure the position of a particle, the less precisely you can know its momentum, and vice versa. There is an irreducible trade-off, a fundamental limit to our knowledge. Imagine trying to measure the position of an electron. To see it, you have to bounce something off of it, like a photon of light. To get a precise measurement of its position, you need to use a photon with a very short wavelength, which means it has a very high energy. But when this high-energy photon hits the electron, it gives it a powerful kick, changing its momentum in an unpredictable way. The very act of measuring the position has made the momentum uncertain. Conversely, if you want to measure the momentum precisely, you need to use a low-energy photon, but this has a long wavelength, which gives you a very fuzzy, imprecise measurement of its position. It is a cosmic game of catch-22, a game we can never win. This principle is not just a theoretical curiosity. It has profound and tangible consequences. It is the reason that atoms are stable. If an electron could have a precise position and zero momentum, it would just sit at the bottom of the atom's potential well, right on top of the nucleus. But the uncertainty principle forbids this. If its position were perfectly known, its momentum would be infinitely uncertain, meaning it could have a huge velocity, and it would not stay there. Instead, the electron exists in a probability cloud around the nucleus, a compromise between being close to the nucleus and having a spread-out position. The uncertainty principle is also the source of the zero-point energy of the vacuum, the ever-present quantum jiggle that prevents anything from ever being truly still. And it has a deep and beautiful echo in our own mental and emotional lives. We can focus intently on one aspect of our experience, a single thought, a specific feeling, a detailed plan for the future. But the more we focus on that single point, the more the vast landscape of other possibilities, other feelings, other potential futures becomes uncertain and fuzzy. We can know the what of our present moment with great clarity, but in doing so, we lose sight of the where-to of our potential paths. As we prepare for sleep, this mental uncertainty becomes a palpable experience. We try to hold on to a single thought, to solve a problem, to plan the next day. But the more we try to pin it down, the more other thoughts and feelings intrude, pulling us into a state of fluid, associative thinking. The conscious, controlling mind begins to lose its grip, and we are drawn into the gentle, welcoming embrace of uncertainty. This is not a failure of control, it is a necessary surrender. It is in this state of mental uncertainty that the creative, restorative processes of sleep can begin. The mind is no longer confined to a single track, but is free to explore the vast, interconnected web of memories, emotions, and possibilities that make up our inner world. The uncertainty principle, at both the quantum and the psychological level, is not a limitation on our knowledge, but an opening to a deeper, richer, and more creative form of existence. It is the universe's way of telling us that not everything can or should be known with perfect certainty, and that in the spaces between our knowledge, in the gentle fog of the unknown, lies the true source of all creativity and all change. Perhaps the most spooky and counterintuitive of all quantum phenomena is entanglement. It is a strange and intimate connection that can exist between two or more particles, a bond so deep that it seems to transcend the normal rules of space and time. When two particles, like a pair of photons, are created in a certain way, their quantum states can become entangled. This means that they are no longer independent entities, but are part of a single, unified quantum system, described by a single wave function. The strange part is that this connection persists no matter how far apart the particles are separated. If you take these two entangled photons and send them to opposite ends of the galaxy, they will remain linked. The real spookiness comes in when you make a measurement. According to quantum mechanics, a property of a particle, like its polarization, is not determined until it is measured. It exists in a superposition of all possible polarizations. But with an entangled pair, the moment you measure the polarization of one photon and find it to be, say, vertical, you instantly know that its distant partner, light years away, will be found to be horizontal if you were to measure it. It is as if the first photon's measurement result is instantaneously communicated to the second, in a way that seems to violate Einstein's cosmic speed limit, the speed of light. Albert Einstein famously disliked this aspect of quantum mechanics, derisively calling it spookhafte Fernwirkung, or spooky action at a distance. He believed that this apparent faster-than-light communication was a sign that the theory was incomplete, that there must be some hidden local variables that the particles carried with them, predetermining the results of the measurements. For decades, this was a philosophical debate. But in the 1960s, the physicist John Bell devised a clever mathematical theorem, now known as Bell's theorem, which showed that it was possible to experimentally distinguish between the predictions of quantum mechanics and any theory based on local hidden variables. In the decades since, numerous Bell test experiments have been performed with increasing precision, and every single one of them has confirmed the predictions of quantum mechanics and ruled out local hidden variable theories. The spooky action is real. The universe is, in some fundamental way, non-local. This does not mean that we can use entanglement to send faster-than-light signals. A measurement on one particle is random. You cannot control whether you get vertical or horizontal. You only know that your friend at the other end of the galaxy will get the opposite result. It is only when you later compare your results, a process that is still limited by the speed of light, that you can see the correlation. But the underlying connection is still instantaneous and profound. It suggests that at a deep level, the universe is not a collection of separate, isolated objects, but a single, holistic, and interconnected whole. This has deep philosophical and even spiritual resonances. Could the feeling of connection we sometimes have with a loved one far away, the sense of empathy that can span continents, the feeling of being part of a collective consciousness, be a macroscopic echo of this fundamental quantum entanglement? As we fall asleep, our sense of a separate, bounded self begins to dissolve. The rigid walls of our individual consciousness become more porous. In the dream state, physical distance often loses its meaning. We can be with people who are long gone or far away. We can feel their presence, hear their voice, experience their emotions. Perhaps in this state, our minds are more attuned to the subtle, the non-local connections that bind us to the people in the world around us. Perhaps sleep is a time when the brain's classical processing gives way, and we become more sensitive to the spooky action of our own entangled emotional and relational fields. Entanglement tells us that separation is, in some sense, an illusion. It is a powerful reminder that we are all part of a single, vast, and mysterious quantum system, a system where the connections are deeper and more profound than our classical intuition can ever fully grasp. And in the quiet intimacy of sleep, we may get our closest glimpse of this fundamental cosmic unity. The thought experiment of Schrödinger's cat serves as a powerful and enduring metaphor for the bizarre and counterintuitive nature of the quantum world. By taking the concept of superposition out of the abstract realm of subatomic particles and applying it to a familiar, macroscopic object, Schrödinger forces us to confront the profound weirdness of quantum reality head-on. The cat in the box, suspended in a ghostly state between life and death, becomes a symbol for the fundamental uncertainty and probabilistic nature that lies at the heart of existence. It is a story that highlights the central role of the observer in shaping reality. The cat's fate is not decided until we look. This raises deep questions about the nature of objectivity. Is there a world out there that exists independently of our perception of it? Or is the universe a participatory one, where the act of conscious observation is what brings reality into being? This is not just a scientific puzzle, it is an existential one. It challenges our sense of being passive spectators in a predetermined universe and suggests that we are, in a very real sense, co-creators of our own reality. This idea finds a powerful echo in our own psychological lives. We all have Schrödinger's cats in our own minds, unexamined fears, unresolved conflicts, unspoken desires, potential futures that we hold in a state of superposition. As long as we keep the box of our consciousness closed, as long as we avoid confronting these issues, they exist in a state of limbo. A difficult conversation we need to have is both had and not had. A life-changing decision is both made and not made. These uncollapsed potentials can create a constant, low-level anxiety, a sense of being stuck. The act of opening the box, of facing the fear, of making the decision, of speaking the truth is what collapses the wave function of our own lives. It can be a painful and difficult process, as we may not like what we find inside, but it is also a necessary one, as it is the only way to move from a state of uncertain potential to a state of definite reality. In this sense, the process of psychological growth and self-awareness is a process of consciously and courageously opening the boxes we have kept sealed within ourselves. Sleep and dreams provide a unique and often powerful arena for this process. In the safety of the dream state, where the stakes are not real, we can often confront our inner Schrödinger's cats in a symbolic form. We can face the monsters that represent our fears. We can explore the alternative paths that represent our unmade decisions. We can live out the consequences of our suppressed desires. Dreams are a kind of nightly, unconscious therapy. A process where the mind rehearses the act of opening the box, of collapsing the wave functions of our own psyche. The state of falling asleep itself is like entering the box. We leave the world of definite, classical reality and enter a liminal space of possibility. The last thoughts before sleep are often a superposition of the day's events and the next day's anxieties, a jumble of memories and anticipations. We are suspended, like the cat, between the past and the future, between what is and what could be. And in the dream state, we are free to explore all of these possibilities. We can see the cat both alive and dead. We can live out both the best case and the worst case scenarios. This is why sleep is not just a passive state of rest, but an active, creative, and transformative process. It is a nightly journey into the quantum heart of our own being, a journey where we confront our uncertainties, explore our potentials, and ultimately prepare ourselves to open the boxes of our own lives when we wake. The ability of a quantum particle to tunnel through a barrier that it classically should not be able to overcome is another of nature's deep and beautiful mysteries. In the classical world, if you throw a ball at a wall, it will either have enough energy to go over the wall or it will bounce back. It will never be found on the other side of the wall if it didn't have enough energy to clear it. But in the quantum world, things are different. A particle, like an electron, is not a solid point, but a wave of probability. And this wave does not stop abruptly at a barrier. It decays exponentially into it. If the barrier is thin enough, there is a small but non-zero probability that the wave will have some amplitude on the other side. This means there is a finite chance that the particle, when measured, will be found on the far side of the barrier, having seemingly tunneled through an impossible obstacle. This is not just a theoretical curiosity, it is a phenomenon that is essential to the functioning of our universe. The sun shines because of quantum tunneling. In the core of the sun, the temperatures are not quite high enough for hydrogen nuclei to overcome their mutual electrostatic repulsion and fuse together in the way that classical physics would require. It is only because of quantum tunneling that they can get close enough for the strong nuclear force to take over and initiate the process of nuclear fusion, releasing the energy that powers our solar system. Quantum tunneling is also at the heart of many of our modern technologies. In a scanning tunneling microscope, a sharp metal tip is brought incredibly close to a surface, and the tiny quantum tunneling current that flows between the tip and the surface is used to create an image of the individual atoms on that surface. The flash memory in our computers and smartphones works by trapping and releasing electrons in a floating gate through a thin insulating barrier, a process that is only possible because of quantum tunneling. But beyond its role in physics and technology, quantum tunneling is a powerful metaphor for the human experience of overcoming obstacles. We all face barriers in our lives: fears, self-doubts, limiting beliefs, societal pressures, past traumas. These can seem like solid, impenetrable walls, and classical, logical thinking can often lead us to believe that they are insurmountable. But the human spirit, like a quantum particle, has a wave-like nature. Our consciousness, our creativity, our resilience are not confined to a single point. We have the capacity to find unexpected paths, to tunnel through the obstacles that seem to block our way. This often happens not through brute force, but through a shift in perspective, a moment of insight, a creative leap of faith. And sleep and dreams are often the crucible where this mental tunneling takes place. In the dream state, the rigid, logical barriers of the waking mind are softened. We are free to explore unconventional solutions, to make associative leaps that our rational mind would dismiss. A problem that seemed intractable during the day can suddenly find a resolution in a dream, not through a step-by-step logical process, but through a sudden, intuitive tunneling to a new perspective. We can wake up in the morning with a strange sense of clarity, a feeling of lightness, a new way forward that was not apparent the night before. This is the power of the unconscious mind to find its way through the walls of our own making. Quantum tunneling is the universe's way of telling us that no barrier is absolute. It is a message of hope, a whisper from the subatomic world that even when the way seems blocked, there is always a possibility, however small, of a breakthrough. It is an invitation to trust in the wave-like, creative, and unpredictable nature of our own being, and to remember that sometimes the only way through is through. The principle of superposition, the idea that a quantum system can exist in multiple states at once, is not just a statement about the properties of individual particles. It is a profound statement about the nature of reality itself. It tells us that the universe, at its most fundamental level, is not a collection of definite fixed things, but a dynamic, vibrant, and multi-layered web of possibilities. Reality is not a single, monolithic entity, but a superposition of all possible realities. This is a concept that is deeply challenging to our classical intuition, which is built on the either-or logic of our macroscopic world. A door is either open or closed, a person is either here or there. But the quantum world operates on a both-and logic. An electron is both a wave and a particle. A cat is both alive and dead. This multiplicity of existence is not something we can directly perceive, because the act of perception itself, the act of measurement, forces a choice. The wave function collapses, and one of the many possibilities becomes the single, experienced reality. But the underlying, unobserved reality remains a rich and complex superposition. This has a powerful and beautiful resonance with our own inner lives. The human mind is not a single, unified consciousness. We are a superposition of multiple selves, multiple desires, multiple beliefs, multiple potential life paths. We contain multitudes, the you who goes to work in the morning, the you who laughs with friends, the you who feels a deep sense of sorrow in a quiet moment. These are all different states, different aspects of a single, complex wave function of the self. We often experience this as internal conflict or indecision. We want both to pursue a safe, stable career and to follow a risky, artistic passion. We feel both love and resentment towards the same person. These are not signs of a flawed or broken psyche. They are the natural expression of our own inner quantum superposition. And nowhere is this multiplicity more apparent than in the dream state. Sleep is the nightly dissolution of the collapsed self of our waking life. The ego, the sense of a single, continuous identity, loosens its grip, and the vast superpositional nature of our consciousness is allowed to come to the fore. In dreams, we can be anyone, anywhere, anytime. We can be a child again, feeling the pure, unadulterated joy of a long-lost summer afternoon. We can be a king, a pauper, a bird, a fish. We can experience the world from a completely different perspective, inhabit a different body, live a different life. These are not just random, meaningless images. They are the exploration of our own, uncollapsed potential. They are the whispers of our other possible selves. Dreams are the theater of superposition, a stage where all the different versions of who we are, who we have been, and who we could be are allowed to play out their parts. This is why dreams can be so liberating and also so unsettling. They show us that our waking identity is just one of many possibilities, one collapsed state among an infinity of others. Superposition, at both the quantum and the psychological level, is a reminder that reality is far richer, more complex, and more mysterious than our everyday. Classical mind can comprehend. It is an invitation to embrace our own multiplicity, to honor the different and sometimes contradictory parts of ourselves, and to remember that even when we have made a choice and collapsed our reality into a single path, the echoes of all the other paths, all the other possibilities are still there, vibrating silently in the deep, superpositional sea of our own being. The phenomenon of radioactive decay provides a fascinating window into the quantum nature of time. A radioactive atom, like the one in Schrödinger's thought experiment, is an unstable system. Its nucleus has an excess of energy, and it will eventually decay, transforming into a more stable nucleus and emitting a particle. But the when of this decay is fundamentally unpredictable. We cannot, even in principle, know the exact moment that a particular atom will decay. All we can know is its half-life, the time it takes for half of a large sample of these atoms to decay. For a single atom, the moment of decay is a purely probabilistic event. It could happen in the next second, or it could happen in 1,000 years. Time, at this fundamental level, does not seem to be a smooth, deterministic flow, but a series of probabilistic quantum jumps. This state of waiting, of existing in an unstable state with a potential for transformation, is a profound metaphor for the nature of time itself. It suggests that time is not a river that carries us along at a constant speed, but a landscape of potential, where events are not predetermined, but are realized through the resolution of quantum uncertainty. The moment of decay is the moment when a possibility becomes an actuality, the moment when the wave function of the atom collapses from a superposition of undecayed and decayed into a single, definite state. Before that moment, the future is open. After that moment, the past is fixed. The decay event is a now, a point where the fog of quantum probability crystallizes into the hard fact of classical reality. This resonates deeply with our own subjective experience of time, especially in the state of falling asleep. As we drift into slumber, our rigid clock-time perception of the world begins to dissolve. The linear progression of thoughts gives way to a more fluid, associative state. Time becomes fragmented, non-linear. A 5-minute doze can feel like an hour. A long night of deep sleep can feel like it passed in an instant. In dreams, the arrow of time can be completely abandoned. We can relive moments from our distant past or experience vivid, detailed scenarios of a potential future. The mind, in this state, is operating on quantum time, a time that is not measured by the ticking of a clock, but by the unfolding of meaningful, emotional events. The decay of an atom is a physical transformation, but we also experience a form of mental decay in our own lives. A long-held belief can suddenly crumble in the face of a new experience. A deeply ingrained emotional pattern, a half-life of sorrow or anger, can suddenly transform, releasing us into a new, more stable state of being. These moments of insight and transformation are often not the result of a slow, linear process, but of a sudden, unpredictable quantum leap in our consciousness. And very often, the seeds of these transformations are sown in the quiet, timeless realm of sleep. Sleep is a state where we let go of our attachment to the linear, forward-moving narrative of our lives. We allow our consciousness to decay, to dissolve its rigid structures, and to be reborn in the morning. Time does not age us. It is our passage through the landscape of possibility, our constant process of collapsing the wave function of our own lives. That shapes who we are. The universe, at its core, is a story of transformation and decay. In all its forms, is the engine of that story. The wave-particle duality is perhaps the most central and profound paradox of the quantum world. It is the seemingly impossible fact that the fundamental constituents of our universe entities, like electrons and photons, behave sometimes like localized, solid particles, and other times like spread out, ethereal waves. This is not a matter of them being one or the other, and we are just unsure which they are. In a deep and fundamental sense, both. Their nature is not a fixed property, but is dependent on the context of the experiment, on the question we ask of them. If we design an experiment to measure their position, to see which slit they go through, they behave like particles. If we design an experiment to observe their interference pattern, to see how they spread and interact, they behave like waves. The universe, it seems, responds to our inquiry. Our choice of measurement determines the reality we perceive. This is a radical departure from the classical, Newtonian worldview, where reality is a fixed, objective thing that exists independently of our observation. The quantum world suggests a more participatory reality, a reality that is co-created in the act of interaction. This duality is not just a feature of the subatomic world, it is a powerful metaphor for our own existence. We, too, live in a state of wave-particle duality. In our waking, everyday lives, we are particles. We have a specific location in space and time. We have a defined identity, a name, a body, a set of roles and responsibilities. We interact with the world as separate, discrete entities. But in other states of consciousness, in deep meditation, in moments of creative flow, in the throes of love, and most universally, in sleep, we experience our wave nature. Our sense of a separate, bounded self dissolves, and we feel a sense of connection to something larger. Our consciousness is no longer a localized point, but a spread-out field of awareness. Sleep is the nightly immersion into our wave-like being. As we drift off, the particle-like identity of our ego, with its sharp boundaries and constant self-monitoring, begins to fade. The borders of the self become porous. We are no longer just me, a single, isolated point of consciousness. We become a flow, a stream of images, feelings, and memories that are not bound by the normal rules of time, space, and identity. In dreams, we are the ultimate wave. We can be in multiple places at once. We can merge with other characters. We can experience a reality that is fluid, symbolic, and associative. The rigid logic of the particle gives way to the poetic, interconnected logic of the wave. This nightly oscillation between our particle self and our wave self is not just a biological necessity, it is an essential part of our psychological and spiritual health. It is a process of rebalancing, of remembering that we are not just our egos, not just the sum of our worldly achievements and failures. We are also something more, something vast, interconnected, and mysterious. We are both the finite particle and the infinite wave. The wave-particle duality is the universe's way of telling us that reality is not a simple, one-dimensional thing. It is a rich, paradoxical, and beautiful mystery. And in the rhythm of our own lives, in the daily cycle of waking and sleeping, of being and flowing, we are living out this fundamental cosmic truth. We are particles of consciousness, dreaming that we are waves. The law of radioactive decay, with its inherent unpredictability, does more than just challenge our classical notions of time. It provides a profound insight into the very nature of its arrow. We experience time as a relentless, unidirectional flow, a river that carries us inexorably from the past to the future. The second law of thermodynamics, the law of entropy, provides a physical basis for this arrow. The universe as a whole tends to move from a state of order to a state of disorder. But the quantum world suggests a more subtle and nuanced picture. The decay of a single atom is not a process that happens in time. It is an event that creates a moment of time. Before the decay, the system exists in a timeless, probabilistic state of potential. The decay itself is the collapse of this potential into a definite, historical fact. It is the crystallization of now. This perspective suggests that the flow of time is not a smooth, continuous property of the universe, but is rather a staccato sequence of such irreversible, information-creating events. The universe builds its past, moment by moment, through the resolution of quantum uncertainty. This resonates with our own experience of consciousness. Our sense of a continuous, flowing present is an illusion created by our minds. In reality, our consciousness is a series of discrete moments of awareness, strung together so quickly that they create the impression of a smooth flow. Sleep is a state where this illusion is temporarily suspended. The mind is no longer engaged in the constant process of creating nows from the sensory input of the external world. It is free to roam in the timeless, probabilistic realm of the unconscious. This is why our perception of time becomes so distorted in sleep. The mind is no longer bound by the relentless, forward-moving sequence of decay-like events that constitutes our waking reality. It is in a state of pure potential, a state more akin to the undecayed atom. But this is not a passive state. In this timeless realm, the mind is engaged in a different kind of work, a work of integration, of healing, of reorganization. The decay events of our waking life, the stressful encounters, the emotional shocks, the difficult decisions leave a residue in our psyche. Sleep is the process by which our minds metabolize these events, integrating them into the larger narrative of our lives. It is a form of mental decay, a process of letting go of the old and preparing for the new. The anxieties of the day can dissolve in the quiet of the night. A difficult memory can be transformed, its emotional charge neutralized. We wake up in the morning, not as the same person who went to sleep, but as a decayed product, a new version of ourselves that has been subtly but profoundly reshaped by the timeless work of the night. The arrow of time, then, is not just a physical law, it is a psychological and spiritual one. It is the story of our own constant transformation, our own continuous process of decaying and being reborn, a process that finds its most profound expression in the silent, mysterious, and deeply restorative alchemy of sleep. The quantum principle of superposition reveals a truth that extends far beyond the realm of subatomic particles. Duality is fundamentally multi-layered, and existence is a constant negotiation between possibility and actuality. This is not just a feature of the physical world, it is a deep and resonant truth about the nature of our own souls. We are not single, monolithic entities. We are a superposition of all our potential selves. The person you are today is just one collapsed state, one realized possibility from an infinite spectrum of potential yous. Every choice you have made, every path you have taken, has collapsed your wave function into a particular reality. But the other possibilities, the other paths, do not simply vanish. They continue to exist as a kind of quantum potential, a ghostly echo in the superpositional field of your own being. This is a concept that can be difficult to grasp intellectually, but it is one that we all experience intuitively, especially in the liminal spaces of our lives, in moments of deep reflection, in daydreams, and most powerfully, in our sleep. Sleep is the great decomposer of the singular self. The ego, with its need for a coherent, consistent narrative, relaxes its grip, and the multiplicity of the soul is allowed to emerge. In our dreams, we are not bound by the choices we have made in our waking lives. We can explore the roads not taken. We can be the artist we chose not to become, the lover we let go, the person we might have been if we had been born in a different time or a different place. These dream experiences are not just idle fantasies. They are the soul's way of exploring its own, vast superpositional landscape. They are a form of quantum exploration, a way of touching and integrating the other, potential versions of ourselves that coexist within our psyche. This is why dreams can be so emotionally powerful. They can bring a sense of profound longing for a life not lived, or a deep sense of gratitude for the life we have. They can show us aspects of ourselves, our courage, our creativity, our darkness that we have suppressed or disowned in our waking lives. They are a form of soul retrieval, a process of gathering the scattered fragments of our own potential and weaving them into a richer, more complete sense of self. The idea that we are a superposition of souls also provides a new and beautiful way to think about our relationships with others. When we connect deeply with another person, we are not just two separate particles interacting. We are two complex wave functions, two superpositional fields, overlapping and entangling. We become part of each other's potential, the love, the wisdom, the pain we share become part of the superposition of each other's souls. This is why the loss of a loved one can feel like the loss of a part of ourselves, a part of our own superposition, a set of possibilities that was realized through our connection with them, has collapsed and is no longer accessible. But the entanglement remains. The connection, the influence, the shared possibilities continue to vibrate within the field of our own being, often surfacing in the quiet, superpositional space of our dreams. Quantum mechanics is often seen as a cold, abstract, and counterintuitive theory, but when viewed through this metaphorical lens, it becomes a source of deep spiritual wisdom. It tells us that we are more vast, more complex, and more mysterious than we can ever fully know. It tells us that our lives are a constant dance between the many and the one, between the infinite sea of possibility and the single, precious, collapsed reality of our lived experience. And it tells us that sleep is a sacred time, a nightly pilgrimage to the superpositional heart of our own soul, a time to remember the infinite possibilities from which we have come and to which we will one day return. The observer effect in quantum mechanics is more than just a statement about the influence of measurement on a physical system. It is a profound revelation about the participatory nature of the universe. It tells us that reality is not a static, pre-existing canvas that we passively observe. It is a dynamic, interactive process, a cosmic dialogue between the potential and the actual, a dialogue in which the observer is a crucial participant. The universe, in a very real sense, is a mirror. It reflects back to us the nature of our own inquiry. If we ask it a particle question, we get a particle answer. If we ask it a wave question, we get a wave answer. This does not mean that reality is purely subjective, that we can create anything we want simply by wishing for it. The underlying probabilities are still governed by the rigorous mathematical laws of the wave function. We cannot change the odds, but our choice of what to measure, our choice of which question to ask, is what collapses those odds into a definite outcome. We are the deciders. This has a powerful and direct parallel in the way we construct our own personal realities. The world we experience is not a raw, objective feed of sensory data. It is a filtered, interpreted, and co-created reality, shaped by the questions we ask of it, the beliefs we hold about it, the attention we pay to it. If we look at the world through a lens of fear and scarcity, we will tend to observe and amplify the evidence that confirms that view. The world will, in a sense, collapse into a state that matches our observation. If we look at the world through a lens of compassion and abundance, we will tend to observe and amplify the evidence for that reality. Our gaze is not passive, it is creative. It is a cosmic act, and this act of creation is not limited to our waking lives. Sleep is a time when the nature of the observer shifts, from the conscious, externally focused ego to the deeper, more symbolic intelligence of the unconscious. In our dreams, we are both the creator of the dream world and the observer within it. The landscapes, the characters, the narratives of our dreams are a projection of our own inner state, our own fears, desires, and unresolved conflicts. But they are not just a passive reflection. The way we interact with the dream, the way we observe it from within, can change its course. In a lucid dream, where we become aware that we are dreaming, this power becomes explicit. We can consciously choose to confront the frightening monster, and in doing so, we may find that it transforms into a helpful guide. We can choose to fly, and in doing so, we collapse the wave function of the dream world in a way that makes flight possible. Lucid dreaming is a powerful training ground for the participatory nature of reality. It teaches us that our awareness is a creative force, that our intention can shape our experience. But even in ordinary dreams, this process is at play. The dream is a constant feedback loop between the unconscious observer and the dream world it is creating. It is a dialogue, a dance. The observer effect, at both the quantum and the psychological level, is a call to a greater sense of responsibility. If our gaze helps to create the world, then we have a responsibility to look with wisdom, with compassion, with courage. We are not just insignificant specks of dust in a vast, indifferent cosmos. We are the universe's own organs of perception, the points at which the infinite potential of the quantum vacuum collapses into the lived, experienced, and meaningful reality of a conscious world. And every night, in the quiet, dark theater of our own minds, we are given the chance to rehearse this sacred creative act, to practice the art of observation, and to remember that the universe is not just something we are in, but something we are doing. The uncertainty principle, with its fundamental limit on our knowledge, is not a statement of failure or imperfection. It is a description of the inherent dynamic and musical nature of reality. It tells us that the universe is not a static and machine-like system that can be perfectly known and predicted, but a fluid, vibrant, and endlessly creative process. The trade-off between position and momentum is not a flaw. It is the source of all stability and all change. It is what prevents the universe from collapsing into a state of perfect static certainty. This principle, which governs the behavior of the smallest particles, is also a profound metaphor for the nature of our own minds and the process of living a creative and meaningful life. We often strive for certainty. We want to know the future, to control the outcome, to have a fixed and stable sense of who we are. We want to know both our precise position in life, our identity, our status, our place in the world, and our momentum, our direction, our purpose, our path forward. But the uncertainty principle suggests that this is an impossible and perhaps even undesirable goal. The more we try to fix our identity, to cling to a rigid sense of self, the more we lose our sense of direction, our capacity for movement and change. Our momentum becomes uncertain. We become stuck. Conversely, the more we focus on a linear path forward, the more we can lose touch with our present reality, with the richness and complexity of our position in the here and now. We become ungrounded, disconnected. A healthy, creative life, like a stable quantum system, is a dance between these two poles. It is a process of finding a dynamic equilibrium between being and becoming, between rootedness and movement, between knowing who we are and being open to who we might become. Sleep is the nightly immersion into this dance of uncertainty. As we drift off, the controlling, certainty-seeking ego relinquishes its grip. We let go of our need to know, to define, to predict. We surrender to the unknown, and in this surrender, the mind is set free. Thoughts are no longer confined to a single logical track. They can move and associate in fluid and unpredictable ways. This is the state of hypnagogia, the creative, dreamlike state between waking and sleeping, a state that has been the source of inspiration for countless artists, scientists, and mystics. It is a state where the uncertainty is not a problem to be solved, but a space to be explored. In the dream state proper, this exploration becomes a full-blown symphony. The normal rules of logic, time, and space are suspended. We can be in multiple places at once. We can be different people. We can experience a reality that is built on the associative, poetic logic of the unconscious. This is not chaos. It is a different kind of order. An order based not on linear causality, but on emotional and symbolic resonance. It is the music of the mind, freed from the constraints of classical certainty. The uncertainty principle is not a pessimistic statement about the limits of our knowledge. It is a cosmic permission slip, an invitation to embrace the mystery, to dance with the unknown, to find peace not in the illusion of control, but in the wise and graceful surrender to the beautiful, unpredictable, and endlessly creative music of an uncertain universe. And every night, as we close our eyes and let go, we are attuning ourselves to this fundamental cosmic rhythm. The concept of the quantum vacuum, the idea that emptiness is not nothingness but a seething sea of potential, is perhaps the most profound and revolutionary insight of modern physics. It inverts our most basic, intuitive understanding of the world. We tend to think of things as being primary and space as being a secondary, passive container for those things. But quantum field theory tells us that the opposite is true. The field, the vacuum, the potential is primary. The things, The particles, the matter, are secondary, emergent phenomena, temporary ripples on the surface of this deep, energetic ocean. This is a worldview that has deep echoes in many of the world's mystical and philosophical traditions. The Buddhist concept of sunyata, or emptiness, for example, is not a nihilistic concept of non-existence. It is the understanding that all phenomena are devoid of any intrinsic, independent existence, that they are all interconnected and arise from a common, underlying ground of being, a ground that is often described as a luminous, creative void. The Tao Te Ching speaks of the Tao as the empty and unnameable source from which the 10,000 things arise. These ancient intuitions, born from deep contemplative inquiry, seem to be pointing towards the same fundamental truth that modern physics is now uncovering through the language of mathematics and experimentation, that at the heart of reality lies a creative, potent, and generative emptiness. Sleep is our nightly, personal journey into this creative void. As the external world of things fades away, as the internal world of thoughts and ego structures dissolves, we are left with the pure, undifferentiated potential of our own consciousness. This can, at first, feel like a frightening loss of self, a descent into darkness and nothingness. But if we can learn to trust this process, to surrender to this inner emptiness, we can find that it is not a void of non-being, but a womb of recreation. It is in this silent, empty space that the restorative and healing processes of the psyche take place. The fragmented parts of ourselves are integrated. The emotional wounds of the day are cleansed. The creative seeds of new ideas and new perspectives are sown. Dreams are the first sprouts that emerge from this fertile ground. They are the first forms that crystallize out of the formless potential of the unconscious. They are the virtual particles of the psyche, bubbling up from the inner quantum vacuum, giving us glimpses of the creative processes that are at work in the depths of our being. This understanding of emptiness as a creative potential can be a powerful antidote to the fear and anxiety that often accompany the dark, quiet, and empty spaces of our lives, both literally and metaphorically. The moments when we feel lost, when our old identity is crumbling, when the future seems like a blank, empty canvas. These are not just moments of crisis, they are also moments of immense creative potential. They are moments when we are closest to the quantum vacuum of our own being, the source from which all new realities can be born. To fall asleep is to practice this surrender, to consciously and willingly enter the creative void. It is an act of faith in the generative power of the unknown, an act of trust that from the deepest silence, a new and more beautiful music will emerge. The quantum vacuum is the universe's ultimate secret, and it is a secret that is not hidden in some distant galaxy, but is present here and now, in the space between our thoughts, in the silence between our breaths, and in the deep, dark, and wonderfully creative emptiness of our own sleep. The non-local connection of quantum entanglement, the spooky action at a distance that so troubled Einstein, is more than just a bizarre feature of the subatomic world. It is a fundamental statement about the nature of reality. It tells us that the universe is not a collection of separate, billiard ball-like objects that interact only through local forces. It is a single, indivisible, and holistic system, where the parts are so deeply interconnected that the concept of separation itself becomes an illusion. The two entangled photons, light years apart, are not two separate things. They are two aspects of a single, unified quantum state. To measure one is to measure the whole system. This profound unity is a truth that is often obscured by our classical, macroscopic experience, where things appear to be separate, distinct, and localized. But the quantum world reveals the deeper underlying reality of interconnectedness. This has powerful and beautiful implications for our understanding of ourselves and our relationships. We are not isolated islands of consciousness. We are entangled beings, connected to the people we love, to the natural world around us, and to the cosmos as a whole, through a web of invisible, non-local bonds. These connections are not just metaphorical, they may have a real physical basis in the quantum nature of our own being. The feeling of empathy, the ability to feel what another person is feeling, the strange synchronicity of thinking of someone just before they call, the deep, unspoken bond between a mother and her child. These are all experiences that defy a purely classical, mechanistic explanation. They hint at a deeper level of connection, a form of conscious entanglement that operates outside the normal constraints of space and time. Sleep is a state where we are particularly open to experiencing this entangled reality. As the conscious mind, with its focus on separation and individuality, quiets down, the deeper, more holistic intelligence of the unconscious comes to the fore. In our dreams, the boundaries between self and other often dissolve. We can merge with other people. We can become animals or objects. We can experience a reality from a perspective that is not our own. We can have vivid, emotionally resonant dreams about people we are deeply connected to, even if they are far away. These are not just psychological phenomena. They may be the subjective experience of our own, real, quantum entanglement with the world. They are moments when our consciousness taps into the underlying unity of the cosmos, the single wave function that describes all of reality. This perspective can bring a profound sense of comfort and meaning. It tells us that we are never truly alone. Even in our most solitary moments, we are part of a vast, interconnected web of existence. The people we have loved and lost are not gone in an absolute sense. The entanglement, the connection, the shared information persists in the quantum field of the universe and can still be accessed in the non-local realm of our dreams. Quantum entanglement is the universe's most beautiful and mysterious secret. It is the physical basis for the spiritual truth that we are all one. And every night, as we surrender to the mystery of sleep, as we let go of our sense of a separate self and dissolve into the dream sea of the unconscious, we are returning home to this fundamental, entangled unity. We are remembering, at the deepest level of our being, that we are not just in the universe, but that we are the universe, experiencing itself, connecting with itself, and dreaming of itself. The dual nature of light, its ability to be both a continuous, spreading wave and a discrete, localized particle, is not a contradiction. It is a paradox that reveals the deep, complementary nature of reality. The principle of complementarity, first articulated by Niels Bohr, states that these two aspects of reality, the wave and the particle, are mutually exclusive, yet both are necessary for a complete description of the phenomenon. You cannot see both aspects at the same time, but you need both to understand the whole. The choice of experiment determines which face of reality is revealed. This is a profound philosophical insight that extends far beyond the realm of physics. It suggests that reality is not a single, monolithic thing, but a dynamic interplay of opposing, yet complementary, principles. We see this duality everywhere in our own lives: light and shadow, order and chaos, being and becoming, masculine and feminine, conscious and unconscious. A full, integrated life is not about choosing one and rejecting the other. It is about learning to hold the tension between these opposites, to dance with the paradox. And nowhere is this dance more apparent than in the daily rhythm of our own consciousness. Our waking life is the particle aspect of our being. We are focused, localized, and goal-oriented. We interact with the world as separate, discrete individuals. We operate in the realm of linear time, of cause and effect, of either-or logic. Our consciousness is like a focused beam of light, illuminating a single point of reality, but our sleeping life is the wave aspect of our being. The focused, particle-like ego dissolves, and our consciousness spreads out, becoming a diffuse to non-local field of awareness. We are no longer bound by the constraints of linear time or a single identity. We operate in the realm of myth, of symbol, of both and logic. Our consciousness is like a spreading wave, interfering with itself, creating complex patterns of meaning and emotion. These two states of being, the waking and the sleeping, the particle and the wave, are not opposed to each other. They are complementary. They are two essential parts of a single, whole human experience. The waking life provides the structure, the action, the engagement with the world. The sleeping life provides the context, the meaning, the connection to the deep, underlying currents of the psyche and the cosmos. Without the focused action of the particle, the wave remains a field of unmanifested potential. Without the deep, integrative wisdom of the wave, the particle becomes a disconnected, meaningless point. We need both. The health of our psyche depends on the graceful, rhythmic oscillation between these two modes of being. To honor our sleep, to value our dreams, is to honor the wave-like aspect of our own nature. It is to recognize that we are not just the solid, definite things we appear to be in the light of day, but also the fluid, mysterious, and infinitely interconnected waves we become in the darkness of the night. The wave-particle duality is not just a paradox of physics, it is the fundamental rhythm of life itself, a rhythm that we are privileged to experience in the most profound and personal way. Every time we close our eyes and surrender to the gentle, wave-like embrace of sleep, the incessant, energetic hum of the quantum vacuum, the constant bubbling of virtual particles in the midst of silence, is not a flaw in the universe's design. It is the very engine of its creativity. The void is not a static backdrop. It is a dynamic, living presence, a field of pure potential from which all forms arise and to which all forms return. This is a vision of the cosmos that is not mechanical and deterministic, but organic, spontaneous, and endlessly generative. The whispers of the vacuum are the first stirrings of existence, the premonitions of a universe waiting to be born. This understanding has a powerful and transformative echo in our own inner lives, the silent spaces of our own consciousness, the moments between thoughts, the pauses in conversation, the quiet stillness of meditation, the deep emptiness of sleep are not voids of non-existence. They are the most fertile ground for our own creativity, our own healing, our own transformation. We live in a world that is terrified of silence, of emptiness. We fill every moment with noise, with distraction, with activity. We are afraid that if we stop, if we become still, we will be confronted with a terrifying nothingness. But quantum physics, and the wisdom of the contemplative traditions, tells us that the opposite is true. It is in the silence that we can finally hear the subtle music of our own being. It is in the emptiness that we can touch the source of all our creativity. Sleep is our nightly, mandatory pilgrimage to this inner sacred silence. As the noise of the day's events and the chatter of the conscious mind subside, we are given the chance to connect with the deep, quiet, generative vacuum of our own psyche. In this state, the mind is not passive, it is incredibly active, but in a different way. It is not engaged in the linear, logical processing of the waking state, but in the holistic, associative, and integrative work of the unconscious. It is in this inner silence that the fragments of our experience are woven into meaningful narratives. It is here that emotional wounds are processed and healed. It is from this fertile emptiness that the seeds of new ideas, new insights, and new solutions to our problems can spontaneously emerge. A dream is a virtual particle born from the vacuum of the mind. It is a fleeting, symbolic expression of the deep, creative processes that are at work in our inner silence. Sometimes these dreams are like the soft whispers of a gentle emotion. Other times they are like the powerful, transformative roar of a deep, archetypal insight, but they all arise from the same source, the potent, creative, and endlessly mysterious emptiness that lies at the heart of our own being. To learn to value silence, to befriend our own inner emptiness, to trust in the wisdom of our own sleep, this is to align ourselves with the most fundamental creative principle of the universe. It is to understand that all true creation, whether of a galaxy, a work of art, or a new and more integrated self, is born not from frantic effort, but from a deep and patient listening to the silent, secret, and life-giving whispers of the void. The quantum nature of time, its refusal to be a simple, linear, and absolute flow, is one of the most profound and mind-altering implications of modern physics. It suggests that our everyday experience of time as a river carrying us inexorably from a fixed past to an open future is a powerful, but ultimately limited, human construction. At the fundamental level, the distinction between past, present, and future may be far more fluid and interconnected than our classical intuition allows. The phenomenon of retrocausality, or backward-in-time influence, which has been tentatively explored in some quantum experiments like the delayed choice quantum eraser, suggests that a choice made in the future can influence the state of a system in the past. This is not to say that we can send messages back in time to change history in the classical sense, but it does suggest that the relationship between cause and effect is not as straightforward as we assume. The universe may be a block of space-time, as Einstein's relativity suggests, where past, present, and future all exist simultaneously, and the flow of time is an illusion of our consciousness. Or or it may be a probabilistic which branching structure, where the future is a set of open potentials that can retroactively influence the path that was taken to get there. Whatever the ultimate picture, the quantum world tells us that time is not a rigid container, but a dynamic and participatory process. And nowhere do we experience this dynamic, quantum nature of time more directly than in our dreams. Sleep is a realm where the linear chronological time of the waking world is completely abandoned. A dream can span decades in a matter of minutes. A moment of intense emotion can feel like an eternity. We can seamlessly transition from a vivid memory of our childhood to a fantastical vision of a distant future. The past is not a fixed record. It is a living, malleable presence that can be re-experienced, reinterpreted, and even healed. A dream can take a traumatic memory from the past and recontextualize it, allowing us to find a new meaning, a new resolution that was not available to our waking mind. The future is not a distant, unreachable shore. It is a field of potential that we can explore and interact with. A dream can present us with a symbolic preview of a challenge we are about to face, or offer an intuitive solution to a problem that has been troubling us. In the dream state, our consciousness is not a passenger on the river of time. It is the river itself. It can flow forwards, backwards, sideways. It can create eddies of memory, rapids of emotion, and deep, still pools of timeless insight. This is not just a psychological curiosity. It may be a direct, subjective experience of the fundamental, quantum nature of time itself. Our brains, as quantum biological systems, may be uniquely attuned to the nonlinear, probabilistic, and interconnected structure of space-time. To sleep is to step outside of the illusion of linear time and to enter into a more fundamental, more real, relationship with the temporal fabric of the cosmos. It is a nightly reminder that the past is not gone, the future is not set, and the present moment is a point of creative potential where all times meet. The dreams we have are not just stories we tell ourselves, they are our soul's way of navigating the deep, mysterious, and beautifully quantum ocean of time. The existence of a multiverse, a vast, perhaps infinite, ensemble of parallel universes, is one of the most extraordinary and mind-bending ideas to emerge from modern theoretical physics. It is not a single theory, but a consequence of several different lines of inquiry. From the many worlds interpretation of quantum mechanics to the theory of eternal cosmic inflation. In the many worlds picture, every quantum measurement, every probabilistic event causes the universe to split into multiple branches, one for each possible outcome. There is a universe where the atom in Schrödinger's box decayed, and a universe where it did not. There is a universe where you turned left at the intersection this morning, and a universe where you turned right. Every choice, every chance creates a new world. In the eternal inflation picture, our universe is just one bubble that nucleated from a vast, eternally expanding quantum vacuum, and other bubble universes, potentially with different physical laws and constants, are constantly being formed. This is a vision of reality that is almost incomprehensibly vast and rich. It suggests that our entire observable universe, with its billions of galaxies and trillions of stars, is just one grain of sand on an infinite cosmic beach. While we can never, even in principle, directly observe or communicate with these other universes, the idea that they exist has a profound impact on our understanding of our own. It provides a potential solution to the fine-tuning problem, and it forces us to confront the true scale of reality. But could we, perhaps, have an indirect connection to these other worlds? Could there be a subtle leakage of information? A faint echo from these parallel realities that we can perceive? This is where the nature of dreams becomes a fascinating area for speculation. Dreams are a realm where the impossible becomes possible, where the logic of our waking reality is suspended. We can encounter people we have never met, but feel a deep sense of familiarity with them. We can visit places that do not exist on any map, but which feel as real as our own home. We can experience lives that are not our own, with different histories, different relationships, different identities. Could it be that in the deep, non-local state of dream consciousness, our minds are capable of tapping into the universal wave function, the vast superpositional state that contains all of these parallel realities? Could a dream be a glimpse, a fleeting, symbolic echo of the life of an alternative self in a parallel universe? This is, of course, a highly speculative and unprovable idea, but it is a beautiful and compelling one. It would explain the profound sense of otherness and yet familiarity that so many dreams possess. It would account for the seemingly infinite creativity and novelty of the dream world. It would suggest that our consciousness is not confined to this single, collapsed reality, but has a deeper connection to the vast multiverse of possibility. In this view, sleep is not just a journey into our own personal unconscious, it is a journey into the cosmic unconscious, a nightly exploration of the infinite library of what could be, and what, in some other corner of the multiverse, actually is. To dream is to be a cosmic explorer, a traveler between worlds. And every morning, when we wake up, we return to our own, the specific branch of reality, perhaps carrying with us a faint, dreamlike memory of the other lives we are living, the other choices we have made, the other stories that are being told in the grand, and perhaps infinite, book of the cosmos. The ultimate mystery that the quantum world presents us with is the mystery of consciousness itself. As we have seen, the observer is not a passive bystander in the quantum drama, but a central and enigmatic character. The very act of observation seems to be what transforms the ghostly, probabilistic world of quantum potential into the solid, definite world of our classical experience. This has led some of the most profound thinkers in physics, from Schrödinger and Bohr to more contemporary figures like John Wheeler and Roger Penrose, to conclude that we will never have a complete theory of the universe until we have a theory of consciousness. The two are not separate problems, they are two sides of the same, deep mystery. The hard problem of consciousness, the question of how and why a physical system like the brain gives rise to the subjective, qualitative experience of being, the feeling of redness, the sound of a C sharp. The feeling of love is perhaps the greatest unsolved problem in all of science. The classical mechanistic view of the brain as a complex biological computer has so far failed to provide a satisfactory answer. It can explain how the brain processes information, but not how it produces experience. This is where the quantum world offers a new, and perhaps more promising, avenue of inquiry. The quantum realm is not just about smallness, it is about a different kind of reality. A reality of holism, of interconnectedness, of non-locality, of unmanifested potential. These are properties that seem to resonate more closely with the nature of our own inner experience than the classical world of separate, solid objects. Perhaps consciousness is not an emergent property of classical computation in the brain, but is a fundamental the quantum phenomenon. Perhaps the brain is not a classical computer, but a quantum one, a biological instrument that has evolved to harness the strange and powerful properties of the quantum world to create the symphony of our subjective experience. In this view, the brain is not the source of consciousness. It is the receiver, the antenna that attunes itself to a more fundamental universal field of consciousness that pervades the entire universe. This would be a return, in a new, scientific guise, to some of the oldest ideas in human philosophy, the idea of a world soul or an anima mundi. Consciousness is not something that we have, it is something that we are, a localized expression of a cosmic principle. And sleep would be the state in which our individual, localized consciousness returns to and merges with this universal field. In the deep, dreamless state of slow-wave sleep, the ego dissolves, the sense of a separate self vanishes, and we are left with a state of pure, contentless awareness. This may be the closest we can come in our human experience to touching the ground state of consciousness itself, the quantum vacuum of the mind. And from this state, as we transition into the REM sleep of dreaming, new forms, new images, new narratives arise, like virtual particles bubbling up from the void. Dreams are the universe's way of exploring its own infinite imaginative potential through the unique individual lens of our own consciousness. This is a vision of reality that is both scientifically radical and spiritually profound. It suggests that our quest to understand the universe and our quest to understand ourselves are not two separate journeys, but one. The secrets of the cosmos are not just hidden in the hearts of distant stars or in the equations of theoretical physics. They are also hidden in the deep, silent, and mysterious nature of our own, conscious awareness. To study the quantum world is to study the mind of God, as Einstein once said, and to study our own consciousness, to explore the depths of our own sleep and dreams, may be the most direct path we have to understanding the deep, quantum magic that underlies all of existence. The universe is not a dead, mechanical thing that happens to contain pockets of consciousness. The universe, at its most fundamental level, may be consciousness, and we are the dreams it is dreaming.
In the beginning, there was no ticking clock, no sun to rise and set, no sense of before or after. Time, as we know it, was not yet born. Then, in a moment of unimaginable force and brilliance, the universe erupted into being, space unfolded, matter scattered. And with it, the strange and elusive current we call time began to flow. But from its very first breath, time has never been as simple as it seems. We tend to think of time as a reliable companion, always moving forward, never stopping. Seconds pass, minutes accumulate, and the hours stretch into days. It's in the turning of the seasons, the rhythm of our breath, and the growth of our children. We measure our lives by it, schedule our hopes around it. And yet, this companion we trust so deeply is anything but constant. Imagine a journey won not across countries or oceans, but across the very fabric of reality. You and your closest friend, once side by side, board separate spacecraft. Their ship accelerates, inching ever closer to the speed of light. You remain behind, watching the stars shimmer and stretch. From your vantage point, time begins to betray its uniform mask. Your friend's ship, once brisk and steady, now creeps forward as if wading through honey. Movements stretch like shadows at sunset. Voices drawl into distorted echoes. Minutes for them become hours for you. But inside the ship, your friend feels nothing unusual. Time remains their faithful ally, unwavering and steady. They sip tea, laugh at old jokes, watch the cosmos stream past, all unaware that from your eyes they are drifting into the slow ballet of time's dilation. This is no illusion. It's the heart of reality, unveiled by Albert Einstein over a century ago. Newton, centuries before, had imagined time as an absolute river, flowing evenly through all corners of the universe. But Einstein saw something deeper, more mysterious. He realized that time was woven into the very tapestry of space, and like fabric, it could stretch and twist, motion and gravity. He discovered were the hands that shaped it. Near massive objects, like black holes, gravity pulls at time itself. Stand close to one, and seconds extend like taffy. Move faster and faster, and time starts to yield, folding in on itself. This is why GPS satellites, orbiting high above Earth, tick slightly faster than our clocks on the ground. It's why astronauts return home a little younger than if they had stayed. These are not tricks. They are glimpses into the hidden nature of time. To truly understand this, we must journey backward back to the beginning. In the newborn universe, all matter and energy were crushed together into a searing, dense cradle. Gravity reigned supreme. In such a place, time crawled. The equations of relativity tell us this plainly. The stronger the gravitational field, the slower time flows. Imagine the first moments after the Big Bang as a frozen tableau, where the universe, still infant and fiery, pulsed in slow motion. Each second was thick with resistance. This warping of time, known as gravitational time dilation, is not confined to the past. It lingers. It governs the flow of time on planetary surfaces and in orbit, in collapsing stars and in the vast vacuum between galaxies. Time is not a universal tempo, but a local rhythm, changing with every step you take. And yet, motion plays its own game. Special relativity shows us that speed, too, slows time. A traveler moving near the speed of light will experience mere hours while centuries pass for those left behind. The twin paradox, a thought experiment turned physical law, illustrates this. One twin remains on Earth, living a normal life. The other soars through space at incredible speeds. When they reunite, one has aged, the other has not. This is not magic. It is the universe obeying its own rules. All of this challenges our senses, our instincts. We want time to be fair, equal, shared. But it isn't. It's shaped by where you are and how fast you're going. It is sensitive, reactive, alive in ways we never imagined. When we gaze at galaxies billions of light years away, we are not just seeing distance, we are seeing old light, stretched and slowed by the journey. Those ancient stars blink at us through the haze of history, their rhythms slowed by time itself. We measure this phenomenon as redshift, the elongation of light waves as they travel through expanding space. But behind this shift is a deeper truth. Time itself was different back then. Quasars, the brilliant hearts of early galaxies, flicker more slowly than their modern cousins, not because they were slower, but because the very universe was dragging time through the mud of expansion. To picture this, imagine a steep valley. At the bottom, near the black hole or the Big Bang, time flows like a sluggish stream. As you climb the slopes, away from gravity's grip or speed's embrace, the stream quickens. This graph of time versus position would not be a straight line, but a curve dipping and lifting, shaped by the contours of space-time. And this brings us to an even stranger frontier time travel. Not just forward, which we already accomplish in small ways, but backward. Here, paradoxes bloom. The grandfather paradox asks, what if you went back and prevented your own birth? The bootstrap paradox imagines a book handed back in time to its own author. Who wrote it? Where did it begin? These are not just riddles, they are tests of our understanding. They expose the fragility of our logic when time loops upon itself. Some theorists propose alternate timelines, parallel universes born from each divergence. Others say the universe would protect itself, never allowing such contradictions to form. And perhaps they're right. But even if time travel remains fantasy, the way time bends and bows is not. It is real, measurable, and deeply unsettling. It tells us that our lives are not ticking along some grand, cosmic metronome. We are each riding our own current, shaped by the hills and valleys of the cosmos. So next time you glance at the clock, consider this: its ticking is not universal. It is a local dialect of time, whispered to you by your place in the universe, in the grand, ever-unfolding story of reality. Time is not a line, it is a living, breathing thing, and we are all suspended in its flow, drifting not together, but apart, each on our own stream, carried by gravity, speed, and the great unfolding mystery of the cosmos. The ancient universe whispered secrets long before language gave them names. In its silence, patterns formed spirals, waves, collisions that echoed across the expanding void. And in that quiet, time continued to ripple outward, touched by forces more powerful than imagination. But the deeper we peer into the cosmos, the more we realize understanding time is not about clocks or calendars. It's about perception, and how the universe stitches past, present, and future into a single, ever-shifting tapestry. Let's descend now into a realm where time is not just a feature of the cosmos, but a lens through which reality itself takes shape. Consider consciousness the spark that lets us mark the passage of time. Without awareness, time becomes meaningless. A rock does not feel the dawn. A wave does not mourn the tide. Only minds like ours give time its rhythm. But what if our very perception of time is flawed? A mirage crafted by biology and bounded by memory. Neuroscientists have long marveled at how our brains carve time into segments. Moments feel longer or shorter based not on duration, but on emotion. A joyful hour with a friend feels fleeting. A minute in fear stretches to eternity. This elasticity is no accident. It is our brain's way of prioritizing experience. But what if the universe, too, experiences a kind of memory? A record of past states etched into its structure. Every particle's position, every echo of a photon, tells a story. The cosmos, in a sense, remembers. In physics, this concept appears as entropy, the tendency for systems to move from order to disorder. Entropy is why a shattered glass won't reassemble itself, why smoke doesn't return to a fire, why time has a direction. This direction, known as the arrow of time, flows inexorably forward, from low entropy to high. And yet, the laws of physics are time-symmetric. If you reverse the equations, they still make sense. So, why does reality insist on marching forward? The answer may lie in the Big Bang. At that first moment, the universe began in a state of incredibly low entropy, an almost impossibly smooth arrangement of energy and matter. From that cosmic seed, disorder bloomed, galaxies formed, stars ignited, and planets spun into existence. In this view, the arrow of time exists not because time itself is biased, but because the universe started with such astonishing order. Imagine a deck of cards perfectly arranged. The moment you shuffle, disorder increases. Each shuffle creates more possible outcomes, more randomness. That's entropy. And just like with the deck, the early universe was exquisitely ordered. Everything since has been a shuffle, and every shuffle drives the arrow of time. But entropy doesn't just explain why time moves forward. It hints at a cosmic memory embedded in matter. The universe isn't just expanding, it's recording. Each new arrangement of particles, each shift in energy, is a page in the story of existence. The past doesn't vanish, it becomes part of the structure of everything that follows. Perhaps that's why the past feels fixed, while the future remains fluid. Now, let us shift from the grand to the granular. Picture a single atom on a distant planet, caught in the orbit of a star we'll never see. Its electrons vibrate. Their probabilities spread across time and space. In quantum mechanics, these vibrations are governed by a mysterious interplay of chance and causality. At this scale, time is not smooth, it's jittery, probabilistic, as if stitched together from quantum fragments. Physicists describe this with the term quantum decoherence. As quantum systems interact with the environment, they lose their indeterminacy and settle into definite states. It's this process that allows the classical world, the one we experience, to emerge from the quantum fog. Time, in this sense, is a byproduct of decoherence. When particles lock into history, the flow of time becomes real. Without decoherence, there is no clear past or future, only a blur of possibilities. This raises profound questions. If decoherence gives birth to time, then time itself may not be fundamental. It may be emergent, something that arises when complexity reaches a certain threshold. In a world of pure quantum states, past and future are illusions. Only the wave function, the full description of all possible realities, exists. And yet, here we are, living, breathing, counting the seconds. So what is the bridge between quantum timelessness and our lived experience? Some theorists propose a model known as the block universe. In this view, past, present, and future all coexist in a four-dimensional structure. Time doesn't flow. It simply is. Each moment is a coordinate in space-time, fixed and eternal. We, like characters in a novel, experience the story page by page, though the entire book already exists. The block universe challenges everything we think we know about free will. If the future already exists, are we truly choosing our paths or merely uncovering them? It's an unsettling idea, one that reframes time as a landscape rather than a river. But perhaps unsettling ideas are necessary when trying to grasp something as elusive as time. Others counter with a model of the growing block universe. In this version, the past and present are real, but the future is not yet. Time grows like a tree, each moment adding to a trunk of cosmic history. This view preserves a sense of becoming, of unfolding, of potential. It aligns more closely with our intuition that the future is open, unwritten. Still others explore loop quantum gravity, a theoretical framework that suggests space-time itself is quantized, made of tiny loops woven into a spin network. If true, then time might be composed of discrete units, like frames in a film reel. Continuity would be an illusion, just as a movie appears smooth even though it's made of still images. This theory would mean that between each tick of the clock, there exists a gap, an invisible breath where nothing happens, yet everything prepares to happen. We are left with a mosaic of possibilities: time as memory, time as entropy, time as quantum emergence, time as a static block, time as a growing organism, time as a flickering illusion of discrete frames. Each model brings us closer to an understanding, but none fully captures the experience of being alive in time. And perhaps that's the point. Time is not just a dimension, it is the stage upon which meaning is born. Our memories give weight to the past. Our dreams infuse the future with significance. Our choices stitch the present with purpose. The more we learn about time's mechanics, the more we are drawn to its poetry. Because in the end, to understand time is to understand ourselves, not just as creatures who endure it, but as beings who shape it through thought, memory, and imagination. Time may be bent by gravity, slowed by speed, blurred by quantum uncertainty. But in every heartbeat, every tear, every laugh, we feel its passage, and that, more than any equation, is the deepest truth we know. The journey continues. In a universe where time stretches and curls like an ancient river winding through alien terrain, our attempts to understand it are like casting stones into water and watching the ripples collide. With each discovery, the surface shimmers anew, revealing depths we hadn't imagined. Now, we turn our gaze to the most enigmatic arenas where time behaves not only strangely, but perhaps incomprehensibly: black holes, cosmic strings, and the potential end of time itself. Black holes are not merely objects of immense gravity. They are gateways to extremes where space folds, light hesitates, and time itself grinds nearly to a halt. As you approach the event horizon, the boundary beyond which nothing escapes the flow of time slows to an imperceptible crawl. To an outside observer, an infalling object appears to freeze, forever suspended on the edge. Yet for the traveler, time remains normal until the final moment, a quiet descent into the unknown. This duality, where time appears frozen and flowing simultaneously, tears at the fabric of our understanding. Inside the event horizon, our equations break down. Space and time trade roles. The singularity, a point of infinite density, is not just a place but a moment in time where all paths end. What lies beyond is beyond our physics, perhaps beyond reason. But black holes may also be keys, not just tombs. Some theorists propose they harbor bridges, wormholes to distant parts of space and time. If such structures exist, they could allow shortcuts through the cosmos or even time travel, provided you survive the tidal forces. This is not science fiction. These solutions arise naturally in Einstein's equations. The question is not whether they can exist, but whether reality permits them. Parallel to this mystery are the threads of cosmic strings, hypothetical defects in spacetime that may have formed moments after the Big Bang. Infinitely long, yet unimaginably thin, they carry immense tension, warping spacetime in strange and beautiful ways. If two strings pass each other at high speed, they might create closed, time-like curves, loops in time. In theory, such loops could allow travel into the past. Yet nature, as it often does, may conspire against such ambitions. The chronology protection conjecture, proposed by Stephen Hawking, suggests the universe prohibits time paradoxes by making such loops unstable. A kind of cosmic firewall might ignite whenever we try to twist time into a circle. Time, it seems, resists being rewritten. As we ponder the far reaches of time, we must also consider its fate. What becomes of time as the universe ages? Cosmologists speak of several endings: the Big Freeze, the Big Rip, the Big Crunch. Each paints a different future. Each reshapes time itself. In the Big Freeze, the universe expands forever, growing colder and emptier until no heat, no light, no activity remains. Time does not stop. It becomes irrelevant. With nothing changing, no events occurring, time loses its meaning. It's a death not of destruction, but of silence. In the Big Rip, the fabric of space expands faster and faster, eventually tearing apart galaxies, stars, planets, atoms. Even time itself may fragment. As distances stretch beyond limit, causality shatters, and the arrow of time dissolves into chaos. The Big Crunch imagines a universe reversing course, collapsing inward until all matter returns to a singular point. Time, running forward all the while, may halt or even reverse in this final contraction. Could we experience our lives in reverse, unraveling memory by memory, breath by breath? There's also the possibility that time is cyclical. Some cosmological models propose a rebirth, a new Big Bang following the collapse. Time, like a phoenix, rises from its ashes. In such a looped cosmos, history might repeat. Are we living a life lived countless times before? Each scenario forces us to ask, does time have an end? And if so, what lies beyond it? If time is a property of our universe, then its end might be the end of everything we can possibly know. Or perhaps, beyond the final tick, lies something stranger, another realm where time, if it exists at all, wears a different face. Still, time's story is not all distant speculation. It plays out intimately in our daily lives. Every human culture has invented ways to market sundials, hourglasses, atomic clocks. We build calendars, celebrate anniversaries, grieve the passing of years. Our lives are narratives written in the ink of time. Even our bodies are timekeepers, the ticking of the heart, the cycling of cells, the arc of aging, all bound to time's flow. But we are more than passengers. We are architects of memory and anticipation, bending time within our minds. Through stories, we travel to the past. Through imagination, we visit futures that may never come. We give time color, meaning, emotion. Art, music, and literature stretch time, folding moments into eternity. A song can make 3 minutes feel infinite. A photograph freezes a heartbeat forever. Through expression, we resist time's erosion. We tell stories not to stop time, but to live alongside it. to make peace with its passing. And yet, even peace is not always easy. Time brings change, loss, endings, but it also brings healing, growth, renewal. The same current that erodes also nourishes. We build dreams on its flow. So as we journey further into the nature of time, we find not just science, but humanity. Not just equations, but experiences. Time is not merely a dimension of the universe, it is the theater in which our lives unfold. To understand it is to deepen our place within it. Now, let us wade deeper into the mystery not through galaxies or quantum loops, but into the nature of time as it relates to identity, memory, and the boundless ocean of imagination. If the universe writes its story in the motion of stars, we write ours through the quiet flickers of thought. And in that inner cosmos, time flows differently. The human mind is a time machine, not made of gears or circuits, but of neurons and stories. We travel backward in memory, sometimes so vividly that the past feels present. We leap forward in imagination, projecting ourselves into futures we hope or fear. This temporal elasticity is not just poetic, it's a neurological truth. The brain does not merely record time, it reshapes it. Studies have shown that when we recall an event, the same areas of the brain that were active during the event reactivate. Memory is not playback, it is reliving. This means the past is not gone. It's reanimated each time we remember. In this way, time within us is cyclical, not linear. A grief from 10 years ago can bloom with fresh tears. A joy from childhood can return with aching clarity. Our inner timeline is a spiral. And yet, memory is fallible. It blends, distorts, invents. We often remember what we wish were true, or what we feared most. The brain edits without our permission, inserting emotional truths where factual ones falter. This is not a flaw, it's a feature. Our memories shape our sense of self. They are less about accuracy and more about meaning. In this light, time becomes not a ruler but a brush, each memory a stroke of identity, painting who we are. And because memory is mutable, so are we. We are not static beings traveling through time. We are fluid, formed anew each moment by the stories we choose to remember. But memory alone doesn't define our temporal experience. Consider anticipation, the emotional resonance of what has not yet occurred. Hope, dread, wonder. These are not tied to the now, but to what might be. Our minds reach forward just as often as they reach back. Time's power over us lies in this dual tension, remembrance and expectation. Religions and philosophies have long grappled with this. In many traditions, time is a path to transcendence. Eastern philosophies speak of cycles, samsara, rebirth, karma as endless loops where time is not escaped, but mastered, enlightenment. In some sense, is freedom from the illusion of time. In the West, time often flows toward a divine culmination, an end, a judgment, a resurrection. Both views imbue time with spiritual gravity. But not all visions of time are hopeful. Existentialists like Heidegger frame time as the shadow beneath meaning. To live authentically, he argued, is to confront the reality of our own finite time. Death gives urgency to choice and weight to freedom. Without time, we would have no stakes, no reason to act. In this view, every moment is sacred because it cannot be reclaimed. The Latin phrase memento mori, remember that you must die, is not a morbid warning, but a call to awaken. To be conscious of time is to honor it. Art captures this reverence. A film is a measured dance through time, each frame a decision, each cut a shift in tempo. Great directors bend time, stretching it in a lingering glance, collapsing it in a montage. They show us that time is not just experienced, but orchestrated. Poets, too, are time sculptors. A single line can contain centuries. A haiku can suspend a second in eternity. Through metaphor, rhythm, and silence, poetry makes time feel, not just pass. Even architecture plays with time. Ancient temples, eroded by wind and rain, remind us of how long a stone can remember. A crumbling facade tells of civilizations past. We walk through cities like layered texts, reading the stories etched in their walls. But what of the time we cannot feel, the deep time of geology and cosmology, the span of billions of years over which mountains rise and erode? Stars form and collapse, species emerge and vanish. This time is humbling. It reminds us that our lifetimes are flickers, brief and bright. And yet, even these flickers leave traces. A child's laughter, a carved name, a whispered idea all ripple forward. In physics, these ripples may echo as gravitational waves, tiny distortions in space-time caused by massive events. But in human terms, they echo in culture, memory, legacy. Perhaps that is the true triumph of consciousness, to leave imprints in time. So, we dance in this tension between insignificance and importance, between knowing we are small and choosing to matter anyway. We measure time not just in seconds, but in stories, not just in change, but in meaning. And meaning, unlike time, can expand endlessly. The clock ticks, the stars wheel, and within each of us, a universe of time pulses quietly. Let us now come to the threshold where understanding turns into awe, where the pursuit of time's nature begins to reveal something even greater: connection. For in all our attempts to dissect time, to measure and model it, what we are truly seeking is our place within it. Time is not merely a backdrop to our lives, it is the thread that stitches us to one another, to the past, to all that might come. We live in time, but we also live through each other. Every conversation, every kindness, every shared silence is an exchange of temporal essence. When you remember a loved one, you do not simply revisit an image you cross time, reach backward and bring them forward into now. In this way, memory becomes a form of communion, and storytelling becomes a time machine that binds people across generations. A child's lullaby may contain echoes of a song sung 1,000 years ago. A sacred text passed hand to hand can carry the breath of the ancients through language. We defy oblivion. But even more than memory, empathy is the miracle that bends time. To feel another's sorrow as if it were your own, to inhabit their moment that is a collapse of separation. It is time folded not by physics, but by compassion. And perhaps this ability to connect is humanity's most powerful defiance of entropy. We build cathedrals, libraries, cities not merely to endure, but to declare we were here, and we mattered. Our monuments may crumble, but the act of building is a statement against the erasure time brings, and though many voices are lost, each one carried forward changes the shape of the future. Consider the legacy of ideas. A thought, once spoken, once written, can ripple far beyond its moment. Newton's laws, Einstein's equations, a poet's verse, a scientist's vision, these do not remain locked in their own era. They radiate. They change the trajectories of lives yet unborn. The present, then, is never just a moment. It is an intersection, a collision of what has been and what could be. And at that intersection stands each of us, finite, yes, but capable of infinite resonance. When we speak of time, we are also speaking of loss. We lose people, places, eras. but we also gain. We inherit. We become. Time's passing is what makes beauty poignant and love enduring. The fragility of each moment is what makes it shine. Like a snowflake melting on a fingertip, its value is in its transience. This is the paradox we must hold. Time both takes and gives. It carves lines on our faces and wisdom into our hearts. It dissolves illusions, but reveals truths. It humbles us, but also empowers us to leave marks that outlast our days. So perhaps the true nature of time is not merely to measure, but to transform. To live in time is to evolve, to create, to heal, to remember, to hope. Time, then, is not the enemy. It is the canvas, and what we paint upon it, our acts of love, of courage, of imagination, those become the constellations by which others navigate. We began this journey at the birth of the universe, among the rippling fires of creation. We traveled through stars and theories, equations and paradoxes. We stood at the edge of black holes, walked the quantum foam, and traced the arc of aging across the soul. We have glimpsed how time bends, stretches, loops, and sings. But in the end, time's greatest mystery may be its invitation, not to solve it, but to live deeply within it. To notice the light in a stranger's eye, to savor the echo of laughter, to forgive and be changed, to love, and let that love ripple endlessly forward. Because while time moves on, meaning does not decay. Every true act resonates beyond its hour. So, as the seconds gather and the stars continue their silent dance, let us not ask what time is, but what we will do with the time we are given. The journey through time is the journey through ourselves. And though the river flows forward, our footprints, our voices, our dreams, these remain endlessly.
Have you ever wondered what time truly is? Is it an invisible river sweeping us through the shores of memory and hope, or merely a mirage our minds conjure to make sense of the universe's chaos? Picture this. You're standing atop a mountain, gazing down at a valley stretching endlessly before you, where sunlight dances on leaves, and for a fleeting moment, time seems to hold its breath. But what if you were racing at the speed of light, or spiraling into the grip of a black hole? Would that moment still mean the same? Welcome to a journey into the nature of time, a concept as familiar as the beating of your heart, yet as enigmatic as the stars glimmering beyond the horizon. In the realm of physics, time is more than a sequence of ticking seconds. It's a dimension, the fourth dimension, woven intricately with length, width, and height to form the fabric of the cosmos we call space-time. Albert Einstein, with a mind that soared beyond his era, revealed that space-time isn't a static stage where planets and stars play out their cosmic drama. It bends, it ripples, and most astonishingly, it shifts depending on who's watching. Imagine an astronaut hurtling through space at near light speed. For them, time slows to a crawl compared to someone rooted on Earth. When they return, their clock might show mere years have passed, while those left behind have aged decades. This isn't science fiction. It's the breathtaking reality of time dilation, born from the elegance of relativity. Yet time isn't just numbers on a dial or equations on a page. It challenges how we perceive the world, beckoning us to dream of voyages across epochs. Could we wind the clock back to mend our mistakes, or leap forward to touch days yet unborn? As physicists probe time's essence, they find it's neither fixed nor absolute. In every reference frame, with every velocity or gravitational pull, time tells a different tale. This fluidity transforms it from a dry abstraction into a gateway to infinite possibilities. A twin on a spaceship ages slower than their sibling on Earth. A clock near a black hole ticks at a languid pace compared to one far away. These aren't quirks, they're windows into a universe where time dances to the rhythm of motion and mass. So join me as we step through that gateway where science and imagination intertwine. We'll unravel not just what time is, but how it shapes the very fabric of our existence. From the ticking of a second to the stretching of eons, time is both our companion and our mystery, a thread tying us to the stars, yet slipping through our fingers like sand. Let's chase it together through the wonders of space-time and see where its currents take us. Delving into quantum mechanics, a new perspective on time. In the heart of modern physics, where the tangible dissolves into the probabilistic, quantum mechanics emerges as a governing principle of the very small. It is a theory that does not merely modify our understanding of reality, it revolutionizes it. Time, once an immutable backdrop against which all events unfold, begins to lose its classical coherence when examined through the lens of quantum theory. The certainty of past, present, and future, so deeply embedded in human intuition, yields to a reality where these distinctions blur, where particles transcend singular states, and where cause and effect entangle in ways that defy conventional logic. At the core of this quantum enigma lies the principle of superposition, the idea that a quantum system does not simply occupy a single state, but rather exists in multiple states at once. Schrödinger's famous thought experiment, in which a cat is both alive and dead until observed, serves as a metaphor for this strange duality. In a classical world, time is a linear progression moving forward in a well-defined sequence, but within a superposed system, events exist simultaneously, seemingly independent of a singular temporal flow. The distinction between before and after dissolves, leaving us with an unsettling question: is time truly fundamental, or is it an emergent property of a deeper, hidden reality? Even more profound is the phenomenon of quantum entanglement, in which two particles, no matter how far apart, remain inextricably linked. A change in the state of one instantaneously affects the other, a connection that appears to transcend the classical constraints of space and time. This eerie simultaneity suggests a universe where time may not be the independent parameter we perceive it to be, but rather a construct emerging from a deeper order, one where separations in time are as illusory as separations in space. If quantum mechanics is correct, and all experimental evidence suggests it is, then our conventional understanding of time may need to be reconsidered. Could it be that time, much like temperature or pressure, is not a fundamental aspect of reality, but an emergent property of deeper quantum processes? Could the apparent flow of time arise from the entanglement of information rather than being an intrinsic feature of the universe? These questions are not merely philosophical musings. They touch upon the very foundation of physics, from the birth of the cosmos to the structure of consciousness itself. As we venture deeper into the quantum realm, we stand on the precipice of a paradigm shift. The rigid, mechanical universe envisioned by Newton and even the relativistic space-time of Einstein may give way to a reality governed by probabilities, correlations, and an intricate web of quantum information. To understand time, we must first embrace the unsettling notion that it may not exist in the way we have always believed. Instead, time may be a thread woven from the very fabric of quantum interactions, an emergent symphony arising from a deeper, as yet unseen harmony of the universe. Quantum time travel, possibilities and paradoxes. Time travel has long been the realm of science fiction, a tantalizing fantasy where past and future become accessible like pages in an open book. Yet, as our understanding of quantum mechanics deepens, what was once mere speculation is now creeping into the domain of theoretical possibility. Could the fundamental principles of quantum physics provide a pathway to traverse time, allowing us to rewrite history or glimpse the unwritten future? If time travel is possible, even in the quantum sense, then the very nature of causality, reality, and human existence must be reconsidered. One of the most promising avenues for time travel emerges from the peculiar realm of quantum entanglement and retrocausality, phenomena that challenge our classical intuition about the unidirectional flow of time. In entangled systems, two particles, no matter how distant, share an instantaneous connection. This has led some physicists to speculate whether information might be transmitted backward in time, creating a bridge between past and future. Additionally, certain interpretations of quantum mechanics, such as the transactional interpretation, suggest that quantum events involve waves propagating both forward and backward in time, subtly hinting at the possibility of influencing the past. Yet, as with all grand ideas, time travel is fraught with paradoxes. The grandfather paradox, a scenario where one travels back in time and prevents their own ancestor from existing, illustrates the logical contradictions inherent in unrestricted time travel. If an action in the past alters the conditions necessary for the time traveler's own existence, how could they have traveled back in time in the first place? Some theories, such as the many worlds interpretation, offer a way out, suggesting that altering the past merely creates a new branching timeline rather than modifying the original. If true, this would mean that time travelers do not actually change history, but rather step into an alternate version of it. If even a limited form of retrocausality were achievable, our perception of history would no longer be fixed. Could we send quantum signals into the past to warn against catastrophe? Could a future civilization transmit knowledge back in time, altering the course of human progress? These are not merely academic musings, but questions that push the very boundaries of physics, touching upon the deepest mysteries of determinism, free will, and the structure of reality itself. The pursuit of quantum time travel is more than an exploration of physics. It is a challenge to the very fabric of our understanding. Whether time is an immutable river or a malleable construct remains to be seen. But one thing is certain: if quantum mechanics holds the key to time travel, then the universe is far stranger than we ever imagined. Time, the invisible thread that weaves the fabric of our existence, is often perceived as an unceasing flow, an unstoppable river carrying us from past to future. Yet, beneath this seemingly intuitive perception lies a profound mystery. Is time truly a continuous sequence, or is the present moment the only point of true existence, with the past and future as mere abstractions? While classical physics treats time as an immutable dimension, quantum mechanics suggests a far stranger reality, one where the past and future may not be rigidly fixed, but exist as probabilities, only materializing when observed. If this is true, then what does it mean to exist in the present? Could it be that the present moment is not simply where we experience life, but where reality itself is actively shaped? Throughout history, philosophers and scientists alike have grappled with the nature of time. In classical physics, Newtonian mechanics describe time as an absolute backdrop against which events unfold, independent of human perception. In this view, the past is a set of completed events, and the future is a predetermined path waiting to be realized. However, Einstein's theory of relativity disrupted this notion, showing that time is not absolute but relative, dependent on the observer's frame of reference. According to relativity, time dilates at extreme speeds and in strong gravitational fields, meaning that what one observer perceives as the present may not be the same for another. Yet, while relativity suggests that time is malleable, it still treats it as a continuous entity. Quantum mechanics, on the other hand, presents an even more radical picture, one in which time may not flow at all in the way we assume. Quantum superposition, the principle that particles exist in multiple states until measured, implies that reality is fundamentally probabilistic. If the future is not predetermined but exists as a set of possibilities, then can we say that it truly exists before it is observed? Similarly, quantum retrocausality, a controversial yet mathematically consistent concept, suggests that present choices may influence past events at a microscopic level. If true, this would indicate that the past itself is not as fixed as we assume, but is also a set of probabilities that only collapse into certainty upon interaction with the present. If past and future exist only as probabilities, then the present moment becomes the point where reality is actively constructed. The famous double-slit experiment provides a striking example of this. When particles such as electrons are sent through two slits, they behave like waves, suggesting that they travel through both slits simultaneously. However, when a measurement is made to determine which slit the particle goes through, it suddenly behaves like a particle, and its wave-like properties disappear. In other words, the act of observation determines the outcome. This phenomenon suggests that the state of reality is not fully defined until it is measured, a principle that some physicists extend to time itself. If our observation is what collapses potential futures into a singular lived reality, then the idea of time as a pre-existing path may be an illusion. The past, too, may not exist in the way we typically assume, but instead emerges in relation to the present. The block universe theory, a concept in modern physics, posits that past, present, and future all exist simultaneously as a four-dimensional structure. But in the quantum realm, this view is challenged by the fact that past events may not be rigidly recorded, but could remain subject to later influences. Living in the present, the intersection of science and philosophy. These ideas are not purely theoretical, they have profound implications for how we live our lives. If only the present moment is truly real, then the weight of past regrets and future anxieties begins to dissolve. In a quantum world where the past is not fixed and the future is still unwritten, we are granted an extraordinary freedom, the ability to shape reality not through deterministic chains of cause and effect, but through the choices we make now. Throughout history, Eastern philosophical traditions have emphasized the importance of present moment awareness. Buddhism, Taoism, and mindfulness practices have long taught that clinging to the past or worrying about the future blinds us to the reality of the present. Remarkably, modern physics seems to echo these ancient insights. If quantum mechanics suggests that reality is constructed in the now, then perhaps the wisdom of living in the present is not just a matter of subjective well-being, but a reflection of the deepest truths about the nature of time itself. Yet, embracing the present is easier said than done. Our minds are naturally inclined to dwell on past events and anticipate the future. However, just as quantum experiments show that observation influences outcomes, perhaps our focus, where we direct our attention, shapes not only our psychological experience, but reality itself. If the past is not rigid and the future is a field of probabilities, then the present is not just where we live, it is where we create. The more we explore the paradoxes of time, the more it seems that the present moment is the only point of actual existence. While memory allows us to reconstruct the past and imagination enables us to anticipate the future, both are mental constructs, representations, not realities. If quantum mechanics is correct, then the past exists only insofar as it remains entangled with the present, and the future is a vast, uncollapsed set of probabilities waiting for observation to give it form. This perspective shifts not only our understanding of time, but our entire way of being. Instead of seeing life as a linear journey from birth to death, dictated by an inexorable march of time, we can begin to see it as a series of unfolding presents, each moment rich with the potential to shape what comes next. This does not mean the past is meaningless or the future should be ignored, but rather that our primary focus should be on how we engage with the now, the singular point where existence and consciousness meet, where reality is not merely experienced, but created. The future of time, unraveling the mysteries. Time, an ever-present yet elusive force, has long perplexed scientists and philosophers alike. Is it a fundamental property of the universe, woven into the very fabric of reality, or is it merely an emergent phenomenon, a construct of human perception? As our understanding of physics deepens, so too does our recognition of time's mysteries. Quantum mechanics, with its counterintuitive principles of superposition, entanglement, and non-locality, suggests that time may not be the rigid linear entity we once believed it to be. Instead, it may be malleable, dynamic, and even subject to influence in ways that defy classical logic. The quest to unravel time's secrets is far from over. In the coming decades, advancements in quantum theory, relativistic physics, and cosmology may redefine our most fundamental assumptions about the nature of past, present, and future. Could time be an emergent property arising from deeper quantum structures? Could it be possible to manipulate time, not merely as an abstract mathematical concept, but as a tangible aspect of reality? As we stand on the precipice of scientific breakthroughs, we find ourselves grappling not only with equations and experimental results, but with the profound philosophical implications of what it means to exist within time. Since the days of Newton, time has been treated as an absolute entity, an unchanging background against which the universe unfolds. This view was profoundly challenged by Einstein's theory of relativity, which demonstrated that time is not universal but relative, stretching and contracting depending on gravity and velocity. Time, in this view, is intertwined with space, forming a four-dimensional continuum known as spacetime. Yet, relativity, despite its elegance, still treats time as a dimension, much like space. It does not fully explain why time appears to flow, or why we perceive a distinct separation between past and future. Here, quantum mechanics introduces an entirely new set of questions. Unlike classical systems, which evolve in a predictable manner, quantum systems exist in superpositions, where multiple states coexist until measured. This raises an unsettling question. If the future exists as a probability distribution, does it already exist in some sense, waiting to be collapsed into a definite reality by observation? Similarly, if quantum retrocausality is real, the idea that present choices can influence past events, then what does that say about the very structure of time itself? Physicists are now exploring these questions with increasing precision. Cutting-edge experiments in quantum computing, entanglement, and wave function collapse may soon provide empirical evidence to support or refute these radical interpretations of time. If time is indeed a product of deeper quantum phenomena, then future discoveries may lead us toward an entirely new framework, one where time is not an immutable feature of the universe, but a fluid, emergent quality shaped by quantum interactions at the smallest scales. With the rapid evolution of quantum mechanics and theoretical physics, several key discoveries could revolutionize our understanding of time in the near future. One of the greatest unsolved challenges in physics is the unification of general relativity with quantum mechanics. Many physicists believe that a successful theory of quantum gravity, such as loop quantum gravity or string theory, will reveal new insights into the nature of time. Some proposals suggest that time itself may be an emergent property arising from quantum entanglement rather than being a fundamental feature of reality. Recent discoveries in quantum physics have introduced the concept of time crystals, states of matter that exhibit periodic motion without energy loss. These bizarre systems challenge traditional notions of thermodynamics and could provide deeper insights into the nature of time symmetry. If time crystals exist in nature beyond controlled laboratory conditions, they could offer empirical evidence that time, like space, possesses hidden structures yet to be uncovered. While time travel remains speculative, some physicists are designing experiments to test retrocausality, the idea that future measurements can influence past quantum states. Certain interpretations of quantum mechanics, such as the transactional interpretation, suggest that particles may send signals both forward and backward in time. If confirmed, this could radically alter our understanding of cause and effect, potentially paving the way for novel technologies that manipulate temporal sequences at a quantum level. The scientific pursuit of time's nature is not merely an academic exercise. It carries profound philosophical implications, particularly in the realm of consciousness and free will. If the future exists as a quantum probability wave, does that mean our choices are predetermined, or do we actively shape reality with each decision? If retrocausality is real, could our present thoughts and actions ripple backward through time, subtly influencing past events? Perhaps most intriguingly, time travel, long relegated to the domain of science fiction, becomes a serious topic of philosophical and physical inquiry. Classical paradoxes, such as the grandfather paradox, have been challenged by new models of quantum mechanics. Some theories suggest that rather than altering the past, time travelers would enter branching timelines, meaning that each change results in a parallel universe rather than a modification of the original. This aligns with the many worlds interpretation, which proposes that every quantum event spawns multiple realities. The implications of time travel extend beyond mere physics. If it were possible to traverse time, even in a limited sense, it would challenge the very fabric of human experience. would knowledge of the future alter our perception of destiny? Would awareness of multiple timelines expand or diminish our sense of agency? If we could send information to the past, how would history itself be rewritten, not just in books, but in our collective memory? As we look ahead, the pursuit of time's secrets is one of the most profound scientific endeavors of our age. Whether through quantum computing, new interpretations of relativity, or breakthroughs in consciousness studies, the nature of time may soon be understood in ways previously unimaginable. It is possible that in the near future, we will no longer see time as a simple progression of events, but as a dynamic, interactive field, one that we are not merely subject to, but active participants in shaping. While time remains one of the greatest mysteries of the universe, its future is clear. It is a frontier waiting to be explored. And as we stand on the cusp of discovery, we may find that time itself is far stranger, more fluid, and more mysterious than we ever dared to dream.